Okay, good evening, everyone. Welcome back to another installment of eBusiness Strategy for 2021. And you will note that there is a notice posted on Eve with regard to the Discord server. So if you do want to join the Discord server, please follow the link in the post indicated over here. You will note that you can either just punch directly into Discord or you can follow the link in your browser and it should launch your Discord app for you to then join the server. Once you're in the server, I'll assign you the student role and then you can ask away any questions that you've got. Please do attempt to make use of the Discord server instead of email for any kind of questions that you do have. The reason being is that very often you get like 2 or 3 students asking the same question about the same topic, and if one student asks it, then the others don't really have to, because they'll be able to then see the information posted on the Discord server. So I do advise you to please join the Discord server. It will be useful, especially during tests and the exam, if you do need to ask questions and get feedback in real time. The reason being is that mail servers can be slow, especially the UJ mail server. So if you send me an email, especially one that has like screenshots or something on it for a problem that you might be having, then it might take a little bit longer for it to come through. So Discord is by far the fastest way to get a hold of me. You will also note that, well, if you're seeing this now, you've seen the lecture information. Every stream is automatically archived, so you can go back and re-watch it if you want to. So just in case you weren't aware, the streams are archived for you to actually go back and watch them. Okay, so I haven't seen any messages in the chat so far, so just first things first, please put a thumbs up if you can hear me. And secondly, if you do have any questions with regard to last week's lecture or the learning guide or the assignments that have been given, the mini research assignment and the main research project, please feel free to drop them as I begin with tonight's lecture, and I will then attempt to answer the questions as we go. So with regards to tonight's lecture, this should be quite a short one, so I'm going to make up for the very long lecture that we had last week. Okay, so tonight we're going to be talking about the internet. I do see some thumbs up, so I'm assuming you guys can hear me. Thank you very much for the feedback. Let's dive into tonight's lecture. So tonight's lecture is going to be about the internet. More specifically, we're going to be looking at the structure of the internet and what the important components are that we need to understand from an e-commerce, or more specifically an e-business perspective, are, and what kind of considerations we need to make as an organization for the use thereof. So let's talk about what exactly the internet is. So most people would consider the internet to be the thing we connect to via Wi-Fi. So most kids would ask, where is the Wi-Fi? How do we connect to the Wi-Fi? And the big thing to take away from the use of the internet is that it's become ubiquitous. It's everywhere. It's all around us. So much so that people don't even really know what the internet is anymore. Most young people would just refer to it as the Wi-Fi. I want to connect to the Wi-Fi so I can gain access to whatever they want to gain access to. But the internet is actually an interconnected network of computers, hence internet. Interconnected meaning they are connected to one another. Now, the internet was actually born from an ARPANET project, and technically it was done by DARPA, which is Defense Advanced Projects Research in the United States, which was designed as a way of decentralizing communications. Because when it came to communications like telephone would be all routed through a central exchange or a central point. So if someone knew where all the exchanges were, it would become quite easy to just blow up those exchanges, and then you would isolate one side of the country from the other because they'd have no way of communicating with one another. So the idea behind the internet is that the internet should be completely decentralized, that communications should not be routed through one single point that could be targeted as a point of failure. So instead, the internet was designed in such a way that everything would be routed dynamically. So if I want to communicate with someone across the other side of the country, I should be able to punch in a destination address, send them a message, and then not need to worry about the actual path that it would take to get to the other side. And this is where TCP and IP, Transmission Control Protocol, and Internet Protocol were developed as a means of addressing certain computer nodes individually and having the ability to then automatically route traffic from one node to the next until it reaches its final destination point. So this is kind of the basis behind where the internet came from. Now, I've listed some videos there if you want to have some more background information. I advise that you go and watch them just to get some background info on what the internet is, where it came from, how it was built, how the first emails were sent. And if you want some more technical explanation, the second set of links, the final link as it were, contains a more technical explanation of how the internet actually works. Now, the reason I've given them as links to you to watch as sort of supplemental content is because I'm not going to ask you about technical things about the internet. How does TCP, how does IP work? Those kind of things. They're not really that important for you to understand from an e-business perspective. We're just going to be leveraging them as a technology which allows us to communicate on the internet and do business on the internet. So more specifically, remember what we did last week. We talked about e-commerce as the act of buying and selling, and more specifically, the use of a monetary exchange taking place. So remember last week we talked about having the internet as the medium by which we would then exchange money and then either facilitate the receiving of goods or services or actually receive them if they are digital goods or services. So this is the important thing that we need to use the internet for. But in order to understand this from sort of a business perspective, we need to look at it based on a little bit more depth. So the little bit more depth that we're going to be looking at is what is called the three-tier architecture or the three-tier model of the internet. And we're going to be looking at this from this perspective because this is sufficient granularity for what we need from an e-business perspective to understand the different things we need to employ, the different roles that we need to have to get our organization up and running, and to leverage the internet as a channel through which we're going to communicate with people. So the things that we need to really focus on is that we need to understand that people are going to connect to the internet via some kind of a device. This picture here shows a very old desktop computer. Most people these days are going to be connecting to the internet through some kind of mobile or tablet-based device. And the way that this is done is that the internet is made up of multiple servers that are responsible for providing the web pages that we need in order for us to actually get the web page that we want and have it rendered on our device. So what initially happens is on your client, you will have a web browser, and the web browser, you will point to some kind of an address, say for instance, Amazon.com. The TCP/IP protocol is responsible for routing your request for a web page. In most cases, it'll be an HTTP request, which is a hypertext transfer protocol, which is used to model what web pages are going to look like, but more specifically, HTTP is going to be used to encapsulate our request for certain things. In this case, the web page itself. And our request is then wrapped up in a TCP/IP packet, routed across the internet to some sort of a web server. The web server then formulates a response and then responds to us using TCP/IP. We then get the response, and our web browser and the device will then render the web page that we see. So there's a lot of things of importance here, that there needs to be some kind of a host or client computer, there needs to be some kind of a web browser, the computer itself needs to be connected via the internet and therefore must be connected to the web server on the other end via these interconnected mesh of nodes. And then there must be a capability for everyone to communicate using a form of protocol. So in this case, TCP/IP are forms of protocol. Now, protocol are very specific set of steps that indicate that something has to happen in particular order. Certain things are expected of you. So a protocol defines a rigid set of steps that need to be executed in order for something to happen. You can think of a protocol as a language. If someone comes to speak to you in English, and you also speak English, it is easy to understand the person. If someone comes to speak to you in a language that you do not understand, it becomes very difficult to communicate with them. And this is why there are these universal protocols that are standardized for the entirety of the internet. Okay, more on that in the next slide though. So for now, we need to understand that we've only done the first two tiers. We've got our client that is going to be connecting to the internet and requesting our web pages, and tier 2 is going to be the web server that's going to respond to those requests and give back the web pages. The third tier of this system is the back-end systems that we've got, and this is normally going to be systems that are responsible for supporting the main web server. Web servers are generally responsible for managing requests made for data about web pages, but very often they don't do much more than that because they might get overloaded. So very often there are other supporting servers that are either hosted at the same site as the main web server or are connected to it. So this web server might request things like products, or it might request order history. Depending on what your HTTP request is, it might request those things from a different location. So bear in mind that these three tiers are going to be, you need a physical client, you need a server to then process requests, and you need something in the back end in order to facilitate all the more specialized functions required for your particular setup. So looking at the next slide, we can see that the internet actually gets broken down into this sort of front end system that the user or the person who's going to be viewing your web page sees, and some kind of a back end that is responsible for data storage, processing, and those kind of things. Now, to make sure that everything actually communicates, we need to have some sort of universal set of protocols to ensure that there's interoperability between all the devices. So if you've got things like Android or iOS devices, they connect to the exact same internet as a desktop PC, the same internet as a laptop, the same internet as a mobile phone or something else. So the important thing here is the internet is designed to be this free, open place where connection only requires you to be able to effectively speak the language of the internet, which comes in the form of the protocols that are used. Now, there are various different protocols, the most basic one being TCP/IP, which is going to be used for the routing and addressing aspects. But then you've got various other protocols that are used for various other methods of communication built on top of the main routing protocols. So those could be things like your HTTP for web pages, HTTPS for secure communications, TSL, various other protocols that do various other more security related things on the internet. So bear that in mind as we move forward, that the internet is this big thing that has to have a universal language for everyone to effectively communicate with one another. So how do we actually enable all of this to work? Well, we enable this through client software. Now, client software is effectively software that is going to be used to interact and do effectively the heavy lifting. Now, when it comes down to clients, there are various forms of clients that can take place and be utilized dependent on your application. You have things that are called thin clients, which are very much dependent on remote services to operate, whereas you get things like rich clients, which will tend to do more of the data processing and require less back-end server. You also have things that are called smart clients, which are responsible for doing a bit of everything all over the place to ensure the best possible experience across different domains. So the idea behind these kind of clients, this client architecture, is that there needs to be a form of client and there needs to be a form of server taking place, because the server very often is going to provide the information. The client then needs to do something with the information. If you want to view the web page, you need to get the data about what the web page is, and you need to then render that web page. So let's dive a little bit deeper into how this all is going to affect us based on the way the internet actually works. So if we look at the basic architecture of the internet, and this is just a very basic example, is that you need to connect your device to the internet via an internet service provider. So you would normally have, let's take an example of a home network. You have your cell phone, you have a fiber box on your wall or an ADSL connection, and you have a router that is then connected to the fiber connection or the ADSL. You then connect to that router either via a wired RJ45 connection, which is an Ethernet connection, or you would connect through something like Wi-Fi. That does not necessarily mean you're connected to the internet. You are only connected to the internet once you are connected from your router, which is responsible for routing your internal network traffic, to the internet service provider. So in this case, we have, say, our home network, and our home network connects to some kind of a modem or a router for ADSL or fiber connection, and from there that would be connected to your fiber box, which is itself a form of router, which is responsible for taking digital signals and converting them into analog light, and then that gets sent off to your internet service provider. Your internet service provider has a set of their own routers, which it is going to then use to route your traffic to other routers for other service providers in order to then hopefully get your traffic from your internal network to some other network somewhere else on the internet. So think about it as you're playing a massive game of hopscotch. You're effectively jumping from one network to another network to another network to another network until you reach the network at the end of your journey. Because when it comes down to internet architecture, it's actually nearly impossible to have one network directly connected to another network. So let's say we work here at Company A. We've got our Company A's internal local area network, or LAN. That LAN would then be connected to a wide area network through the ISP, which will have some kind of routing technology that will have physical cables or satellite-based cables or something along those lines. Radar dishes and long-range wireless transmission are also possible, that would then connect your network effectively through a set of other networks to some set of backbone routers. And the backbone routers are high-density network switches that will be responsible for quickly routing network packet information through backbone connections. So think about things like your CCOM network cable that connects Africa out to the rest of the world. So if ever you've had a really slow internet and you've heard a news report, oh, CCOM is down, that's because a backbone internet connection is down, which means there's no way for us to actually physically connect through that normal route, which means traffic has to actually be routed through other exchanges, other backbone routers, other backbone connections around the world. So we might actually have to go out through to South America, up through America, across through Europe, and it'll be much slower that way than having a direct connection up through Africa and out through to Europe. So if you think about it, the internet, the net portion of it's actually very important, because there are multiple different devices that are going to be connected and networked together in order to facilitate the whole transmission of data across the globe. So in a funny story that I like to quote, Armenia actually had one single backbone network connection that was laid in the country that connected it effectively to the rest of the world. And someone decided to do some gardening one day and accidentally put their shovel through the actual backbone network connection. And that effectively cut off Armenia from the rest of the world. This is a story back from 2011, but I still think it's hilarious. And it just goes to show that there is a need for redundancy. If you've got just one connection that is connecting you to the rest of the world, it makes it far easier for that connection to fail if someone puts a shovel through it, someone targets it for an attack, or something along those lines. So in terms of having a decentralized connection, you also need to have redundancy. Okay, so how much of this do I actually want you to be able to memorize and be able to answer questions about? I don't actually need you to draw diagrams about this. I don't need you to tell me what TCP/IP protocols are. I just need you to understand that the internet is this network that we are using. It connects people. It has rules in the form of protocols. It has client front ends. It has server back ends. And in between all of those things, that is our space to effectively execute our e-business strategy in order to get our e-commerce to work effectively. Okay, so let's talk about some internet technologies. We've already talked a lot about TCP/IP. TCP/IP provides the means by which we are able to transmit data and address that data so that it can get from one place to the next. That is about all the information I need for you to understand. One thing you could understand from that is that you need to have some kind of an address. This address is normally in the form of an IP address, which is going to be an IPv4 address, which is a numeric address, or you have something like an IPv6 address, which is an alphanumeric address. But human beings are not very good at remembering numbers, so that is where a uniform resource locator or URL comes in. Because humans aren't good at understanding and remembering number sequences, names are very often better understood. And this is where a URL comes in, which means a URL needs to fulfill the role of addressing. Well, it actually doesn't really fill the role of addressing. A URL is used to supplement an address. So you will specify that yourwebpage.com has a particular IP address associated with it, which means if you want to go and connect to yourwebpage.com, something is going to need to get the actual address of it. Take for an example, you want to go and deliver your tax return to SARS. Well, you're not going to navigate to SARS. You first need to find the address of the particular SARS building that you want to go to. You then go to that address to find the company that you're looking for, in this case SARS. So that is the job of the URL. The URL provides an easy to understand name that can be referred to, but then it will be translated into an actual IP address so that communication can be done using the TCP/IP protocol, which provides the basis for networking on the internet. So you're probably pretty familiar with the way a URL looks and works. You specify your protocol first. Generally it's HTTP, HTTPS. If you're going to be doing other things like transferring files, you can do it via FTP. So you specify your protocol and then you specify your domain. So the domain is going to be the place you're going to. It's usually going to be in the form of the name of the company dot the top level domain, com.co.uk, .org, etc. And from there you can specify subdirectories, specific resources, all dependent on the way that the URL is actually structured. So that will all then depend on the actual structure of the way the web page was set up. What I want you to take away from this easy to understand human name needs to get translated into an actual address, an IP address for communication to take place. Now, how does this communication take place? Well, it happens using more protocols. The most common protocol is going to be HTTP, or Hypertext Transfer Protocol. This is done for tier 1 of the internet architecture to communicate with tier 2. You want the client to be able to communicate with the server so that they can get the web page, so that they can get the data that they want. You can also have it that a lot of organizations have what are called proxy servers, which are responsible for limiting access in some way. They act as an effective proxy so that you communicate with the proxy server communicates with the real server, but sometimes the proxy server will do things like filter out nonsense requests, or limit certain people, certain requests from certain addresses, and filter those kind of things out to make sure that the internal network is not affected from unreasonable requests such as denial of services or floods from outside networks. There are also things which are important to store in the form of cookies and other similar things like beacons and identifiers. Mostly on mobile devices, you will have identifiers which are used to uniquely identify your device so that you can be targeted with advertising information. Now, when it comes down to the use of cookies, we look at them from the perspective of ease of use, that cookies generally store a form of token on your device, which makes it easier for you to do whatever you want to do the second time you return to a web page. So instead of having to sit and log in and do everything again, a cookie could store a session token that will get renewed when you revisit the web page again. If the session token has expired, it can then be renewed the next time you arrive. The idea is it will store some kind of unique information about you and your experience to make your interactions with the website better. Conversely, it will also enable the web page to glean some information about you and see that you are a returning customer, when you were last here, and various other things dependent on what was actually stored inside the cookie. Okay, so these are sort of the higher level things to understand. Back to the low level things, I did allude to the fact there is different addressing methods. So IPv4, we use this mostly for internal networking. The reason being is internal networking, such as in your home network, you don't need that many addresses. It's only a 32-bit address space, which means there's actually not that much space. If we were to actually assign an address to every device on the planet using IPv4, there actually aren't enough addresses. Whereas with IPv6, which is currently being rolled out and put into use, there is actually enough address space there for all the devices on the planet for the next few decades at least. So think about it that IPv4 has been around for a very long time and has its limitations in place on the number of addresses that it can possibly use concurrently. A lot of internet service providers do not provide what are called static IP addresses because they actually just don't have enough IP addresses to give to everyone. So instead, you have a lease on an IP address that when you disconnect, it will then release your IP address so that someone else can make use of it. This is a very common thing, especially in South Africa. Okay, so if you want to dig a little bit deeper, here is a comparison between IP addresses 4 and 6. So IP addresses are numeric or dot decimal because they are sequences of 3 numerals followed by a dot followed by more numerals. When it comes to IPv6, it's all in hexadecimal. So the characters 0 to 9, A through F are all possible letters that can be used in IP addressing. So if you think about it, you've got here what 10 times 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 10 and times some more 10s, number of addresses. But in this case, you've actually got 15 characters, which increases the complexity a lot and gives you a far larger pool of addresses to work with. Okay, so when we consider these, the big changes that are happening is that with IPv6, it's a larger pool of addresses that we're looking for. But also it's aimed to have increased security as well as support for mobile devices. Exactly how this is implemented, well, it depends on how it's actually used at the end of the day. But again, this is not the most important thing. The important thing is this is just the way the network works in order for communication to take place. So instead of using your home address, which has like a number, a street, a province, and a postal code, you now have this IP address, which is a sequence of characters that are there to uniquely identify your device so that traffic can be uniquely routed to your device. You don't want someone else on the other end of the world getting packets that are meant for you that have your data in. You want to have your packets coming to your device so that you can do what you want to do on the internet. Okay, so another layer of complexity built on top of the internet is that of cloud computing. When we consider the three-tier model of the internet, we normally consider there's a client device, there is a physical server somewhere. So a company would have their server, which is their web server. They'll have their mail server. They'll have their back-end fulfillment servers. It's all their servers. That was normally the case about a decade ago. In more recent times, because of the abundance of computing power and the ability to cram far more data into the same space by means of Moore's law, where you're going to have your computing power increase and your size decrease, cloud computing is a natural evolution by which an organization no longer needs to actually store their own servers and manage their own servers. Instead, what is going to be happening a lot of the time is large organizations will create their own pools of servers using virtual machines that can then be used to host other people's web pages and servers and services. So you as a company don't need to buy your own physical hardware for your web infrastructure for tier 2 and 3. Instead, you can outsource that to another organization entirely, which means that you can then host that off-site. So if you're an organization that doesn't have the skills or the people to actually maintain that physical infrastructure, well, you don't have to anymore. You can just pay someone else to do it for you. So think of Azure, Amazon Web Services. These are all going to be organizations that provide you with some kind of a package which enables you to take what you want to do on the internet in the form of your sort of service as a web server or back-end service, and then host it on someone else's infrastructure and just pay them a subscription fee to do so based on either a contract or based on your usage. So when it comes to organizations, a lot of organizations look to cloud services in varying degrees. So small organizations don't really have the skills or money to invest upfront in hardware infrastructure in the form of very expensive servers to manage their websites and their payment platforms and everything that they need for their organization to run. So instead of doing that and then hiring the people on top of it to have it managed, instead they will outsource their infrastructure requirements to a web hosting platform, and they will then get someone else to host their website for them. For mid-sized organizations where they do have the technical staff but they don't want to spend lots of money, it can be useful to have a less managed package that you yourself can tweak and manage using your own skilled staff. Now, when it comes to large organizations are very going to use cloud computing as a form of scalability, because sometimes you have someone come to your website, sometimes you have 10,000 people come to your website. It's not going to be consistent all the time. So one of the advantages of cloud services and the ability to spool up additional virtual machines is that you can bring online additional virtual machines when necessary and then turn them off when they're not needed. So this scalability is one of the big advantages of cloud computing. It also means that you don't need to invest in the worst case scenario and buy the biggest, baddest server or 10 of them to handle your peak loads. Instead, you just rent out server space and just pay a bit more during the peak times, but then you then pay a bit less during the non-peak times. So if we look at cloud computing from this perspective, there are actually 3 different things that can really be offered. Number one being cloud computing can offer you applications, out of the box software on the internet that you can use. Think about this like your Google Apps. You want to be using a word processor or a spreadsheet, but you don't want to install it on your computer. You can use a remote application to do that for you. So if you wanted to, you could outsource all of your applications to the web so that you can have a very lightweight computer but still be able to do all the processing required. However, the processing is done off-site, which means you've got to really consider the data security. What kind of information? Are you happy with the fact that all of your information is going to be stored on someone else's server off-site? So those are all things that you need to consider and weigh up. We will talk more about these kind of considerations later on in the course. Other things you have are frameworks, where they do the initial setup by putting the virtual machines in place, and they give you the ability to just deploy to the virtual machine. This is what happens in the case of things like Microsoft Azure, where they give you the database framework, they give you the virtual machine, you just deploy your website to it, and it then is brought online, and the services begin running for you. Other things that can be provided come in the form of hardware. Now, hardware is more, we give you access to this hardware, here is your web address, it becomes associated with their hardware, you rent out the hardware, they maintain the hardware, but you then have direct control over what happens on that hardware. So if you burn it out, well, that might be a bit of a problem, but they will fix it, you'll just have to pay for it. So what is the big thing about this cloud computing? Cloud computing gives us the ability to almost simulate infinite computing. And that's important because there's been a lot of advances in cloud computing, especially with regard to heavy processing loads that were not be feasible to do locally. A lot of GPU-based applications or graphical processing unit applications, such as video games, such as image and video processing for pattern recognition technologies. A lot of those take exorbitant amounts of computing power that is just not feasible for everyone to go out and buy. So instead, you can rent cloud computing space to do the important heavy lifting for you when you need it. So you've got this on-demand platform for access to computing power and resources when you need it. And the great thing about this, it means that you can have any number of different media on the internet that can be handled by these platforms that you yourself don't need to actually worry about, which means your organization can begin focusing on the things that are most important to your organization. That is making money, getting the organization actually running financially viable and effectively turning a profit. So this brings us down to this like big decision that a lot of organizations have, is that do they host their own web page, do they manage their own web page, or do they offload it to someone else to do as a cloud service? So let's look at some of the considerations that we've got when considering the two. Now, there are different ways of deciding on whether or not you want to have an on-premise solution or a cloud service that you're going to be paying for. And very often the most important thing that people are going to have to consider in an organization is the price. Sometimes the price is not the problem. Sometimes the price is going to be the support. If your organization does not have the people to actually set up a web server, then you have to factor in the actual cost of the hardware plus the cost of acquiring the skills to do it for you. And this could often be exorbitantly expensive for a very small organization. If a small organization only has a very small margin of profit, they don't actually turn a lot of profit, which means they can't narrow that margin by hiring additional staff just to maintain a website or maintain a web server, then maybe having your own physical servers in place is not going to be the best way of doing it. So a lot of the time, the organization might also consider things like what kind of services are available from the cloud platform. Services that we'd otherwise have to buy or develop. And instead of having to buy or develop them, they might come as a part of a package associated with that particular web service provider. So it might be a more enticing bundle to instead for a small organization to get a cloud service. But let's compare this now from the perspective of a larger organization that does have a lot of money. They do have the skills to support this. They do have the developers to develop things. Large organizations might actually want to instead have their own physical servers because they know exactly where the servers are. If there's a problem, they know exactly where the on-off switch is. If there is any question about the data, they know exactly where the data is stored. It's not like it's held elsewhere on the internet. So if you've got a cloud service provider, they store your data. Yes, they will encrypt your data in order to assure you that it is safe, but it isn't really safe, because if you've seen things like the Apple data breaches, Facebook data breaches, there's been lots of data breaches that have come from off-site storage of data. Now, having a physical server that you maintain and own might actually be worse in terms of data breaches, because large organizations will go about patching and ensuring security across all organizations that use their services. Whereas if you've got your physical server that you've purchased and that you're maintaining, the onus is on you to ensure that you're got the latest patches installed, that you've got the right kind of encryption that you're using, that your key lengths are long enough, that you're using the right encryption algorithms. And if you don't do those things, in certain places in the world, you actually become liable should the data be breached, and you can be subject to fine and obviously the loss of face that comes with having your people's data that you were protecting being leaked onto the internet. So it becomes a very large balancing act for an organization. Do we want our own physical server that we have to maintain and manage and be liable for? Or do we want to offload this to a different organization that then they are responsible for patching, maintenance, those kind of things? We just have to pay them a lot of money to do that, but we get peace of mind as an organization. So what I want you to do is I want you to think about this from the perspective of an organization who has a lot of money versus one who does not have a lot of money, one who has a lot of skills versus one who does not have a lot of skills, one who is adverse to risk versus one that is a bit more welcoming of risk because they have the competence and they have the skills to mitigate those kind of risks. So it's going to be a balancing act, and a lot of the time this balancing act is going to come down to one large calculation, and this large calculation is going to be the total cost of ownership. An organization will have to take into account the entire cost of running a server or a farm of servers to meet their needs versus the cost of actually outsourcing it to someone else. Total cost of ownership is going to involve absolutely every cost involved in the acquisition, development, implementation, installation, maintenance, etc. of the system throughout its life. Now, a lot of the time, that cost will be too high upfront for most small organizations to be able to stomach. So instead, they will opt to rather go the cloud route because it requires less upfront investment, but a larger investment over time for them to make use of someone else's services. So when this comparison is done, you have to look into a lot of associated costs like hiring of people. So there's a question here. It says, surely on-premise solutions can also be hacked? So the answer is yes. And that's where it comes down to that discussion I was having on the patching, the maintenance, the security aspects of it. That yes, they are just as at risk as some cloud service provider. The only difference is if it's your servers that get hacked, you're the one who's supposed to be maintaining them, ensuring the best standards are upheld, patching is done, etc., which means your organization becomes liable. Now, obviously, this is all dependent on where the servers are hosted, what the jurisdiction is, what the local laws are. But very often, a lot of organizations would rather pass the buck to a cloud service provider and say, they didn't patch and maintain our servers, therefore, they were the ones who were responsible for the data actually getting breached. It isn't us as the organization, we will pass the buck to them. Now, in certain jurisdictions, that is something that is possible, in others, not so much. So, to answer your question shortly, yes, on-premise solutions can be hacked. Sometimes they are far more juicy and easy targets because a lot of organizations neglect security considerations, which means they will more than likely get hacked because a lot of attackers know that companies that maintain large server farms are far more at risk of being attacked because of just the number of servers that they maintain and manage for various clients. Therefore, they tend to do a better job of keeping up to speed on patching and keeping the security in line. Okay, so let's have a look at some of these total cost of the different kind of ownerships that can take place. So if we look at things like servers, servers are an upfront expense that you have to pay. They're what we call a capital expenditure. So if you want to buy servers, you have to buy the physical servers. But then you also have to buy the software that goes on them, you have to buy the licensing, you have to buy the operating systems, you have to then buy additional hard drives to do backups, you have to then look at things like how you're going to be hosting things. You're going to be hosting it on bare metal, you're going to be using virtual machines, how are you going to be doing it? You then have to look at things like who's going to actually do this. Whereas if you look at things that are going to be a cost to you over time, they're going to be things like server hosting. These are what we call operational expenses. Now, operational expenses are much lower expenses, but they tend to pile up over time. So if you buy a server now, you pay a large amount of money up front, whereas if you host a server, you pay for hosting of a server, you're going to pay small amounts of money over a longer period of time. So depending on the period of time, it might be more cost effective to buy the server up front than host it on someone else's servers for 5 years, for instance. So if we think about it, it becomes a balancing act. Your organization has to look at a time frame and has to look at what their requirements are and how much money they've got available, how much experience they've got to actually execute on this plan, and then weigh these up. So when it comes to something like a semester test or an exam, I might give you 2 organizations, or I might give you 1 organization and give you the situation of the organization. The organization has a lot of money, it has no experience, it has no people, but it's not got any sensitive data, and I might ask you to argue which one should you have, an on-premise solution or a cloud solution. And I want you to kind of back that argument up with the data that is existent in the case study that I'd give you or the situation of the organization, and really just try and explain to me why you think the company should go with, say, a cloud operation versus an on-premise operation. So those are the kind of things you can look forward to in terms of tests. Now, that is effectively what I want you to think about when it comes to these cloud versus hosting versus internet at large, is that all of this becomes really a hosting platform. The hosting platform is going to be where we're going to put a web page. So another question here is, for larger organizations, would it be more convenient to go for cloud solutions instead of on-premise solutions, assuming they can afford the operational costs? So it really depends. Some organizations might want to go and outsource because they can afford to do so. They can afford to outsource. They can go with either approach, but they might feel that they don't want to maintain the servers. Therefore, they might want to rather go for cloud, even though they can themselves host and buy their own servers and maintain their own servers. A lot of organizations want to focus on the core business aspects that they are good at. Some organizations are good at selling products, developing products. They don't have a department dedicated to maintenance of servers, creation of web pages, maintenance, those kind of things. So instead, they would rather outsource that to another organization so that their organization can focus on what they are good at. Some organizations might also want to outsource the hosting of web pages to a neutral territory. So they might want to put their web pages on servers that are in a country where they can't be subpoenaed to get data. So shadier organizations might want to do things like that, where the server is located in some territory that can't get a takedown notice, can't be subpoenaed for data, and therefore is out of the jurisdiction of whoever's wanting to access it. So a lot of United States-based organizations will want to host their servers somewhere else in the world. So if they are subpoenaed, they can go, well, we don't have access to that data. Those kind of things. So that also is a big problem with the way the internet works, is that because it's across the whole globe, how does jurisdiction work? So that also ranges from different region to different region. So just moving along to the final topic of tonight's discussion. I hope that answers your question. If it doesn't answer your question, feel free to drop another question. I'll try and clarify for you. The last thing I want to talk about is emerging technology trends that could affect the way the internet works or the way we do commerce on the internet. Now, the biggest one we've seen lately is the use of mobile applications. Every company and their brother wants you to install their mobile application. Are you tired of going to a website and they tell you they have a mobile app, install our mobile app, and you're like, this is the first time I'm visiting your website. Why do I want to install your mobile app? But that's something to consider, that mobile applications are taking over the world and people want to get you onto their mobile application so that they can then harvest your data and do various things in a more streamlined fashion. So I'm glad the question was answered. In terms of other technologies, push notifications. How many times have you seen adverts from an organization directly come through push notifications? The reason push notifications work so well is because if you have the app installed, there's pretty much an assurance that you're invested or interested in the products that they offer. Therefore, they have a direct marketing line to tell you when they had specials on, sales on, those kind of things. Location-based services can also be used to do things like tailor products and services to you. If they know that you live in the southern hemisphere in a place that's very hot, they'll probably want to sell you summer clothing rather than winter coats at certain times of the year. So it can tailor, again, what kind of information they know about you and what kind of services they can offer to you. Other things can be things like social sharing, which is social media, sharing of information, sharing of, absolutely anything pretty much. You can share advertising through social media. You can actually have entire storefronts through social media applications, as well as having the ability to rate, review products and share to establish what consensus is on a particular object. So if you want to buy something, you go and look at people's reviews of it to see if it's any good. If you don't see many reviews, you know not many people have bought the product, or the product's very new. You could wait for reviews to see that people actually like the product, enjoy the product, see if the product's actually a piece of quality or a piece of junk. Other things are monetary systems. Mobile wallets, having the ability to actually store money, pay directly from mobile devices, so you don't have to actually use credit cards, checks, physical cash. Those kind of things are taking over the world. New trends such as cryptocurrency have taken over. It went through a great dip. It's now in a giant resurgence at the moment. So it is gaining traction that having decentralized money is actually something can be possibly a technology of the future. Whether or not it'll be Bitcoin or one of its competitors or a completely new iteration in a few years, we don't really know. If you're willing to risk money and prospect on it, well, you could make a lot of money. You could also lose a lot of money. So it's really up to you. No financial advice whatsoever is offered in this particular course, so please do not ask for any. And one thing I want you to consider is what could possibly be the next thing? What could be the next disruptive trend that could affect the way that we do business on the internet? Now, that if anyone can predict what that is, they could then stand to make a lot of money off of whatever that trend is going to be. So the idea behind all of this is I want you to think about what the constituents of the internet are. Who are the people? What is the information? How is the information transmitted? Where is it stored? What effect does the information have on the people, on the services, on everything? Because the internet is not just a web created of physical computers. It is a web of information. Information that relates products, it relates people, it relates services, it relates technologies, all to one another. And if you can see and understand these technologies, you become better equipped to move an organization into a position where they can develop the right technology, the right product, the right service for their needs, for not just where the organization is now, but where the organization could prospectively be in 5 years' time. So that's why we do this lecture on the internet, is that yes, it's there. It's something that's been around since the 70s. And it is something that's going to be around for a very long time. But it is something that we need to understand, not necessarily at a very finite granular level, but something we need to start seeing the larger picture of so that we can position an organization to be in the best possible place to interact with the internet. And the people who live on the internet, that's you, that's me, that's everyone who actually connects to it and exchanges data on it. So those are going to be the people that you want to get information from, the people you want to sell things to. Okay, so ladies and gentlemen, that is all I have for you tonight. If you do have any questions, or any further questions rather, please feel free to post them here. If you have not done so, please join the Discord server so that I can then assign you the student role. And if you want to ask any questions there, you are welcome to ask them there. For those of you who do not have any questions and have already joined the Discord server, please enjoy the rest of your evening and have a good week further, and I will then see you back here next week for another lecture. If you do have any questions relating to the projects themselves, either the mini research assignment or the main project, please do ask them. If preferably before next week, so that I can dedicate some time in next week's lecture to actually discussing any of the points that you don't understand or if there's any confusion. Okay, for the rest of you, have a great evening. Okay, I'm not seeing any questions coming through, so I'm going to then conclude tonight's stream. If you have any questions, please post them on the Discord server. Have a good evening, thank you, and good night.